Okay, so here we have that we are asked to prove that CAX is congruent to QAM. So CAX congruent to QAM is what we are asked to prove. And so we can see that those are vertical angles, but we are going to have to prove it. So the way that we are going to go about that is by saying that these two are supplementary and these two are supplementary. So since they both sum to be 180 and they share this angle, I'm sorry, no, that's not the way it's going to go. We're going to do those, and we're going to do these two. And so since they share this angle and they both add up to 180, they must be equal to each other. And so CAX and XAQ are supplementary. Let's mark it. That's a linear pair. XAQ and QAM are supplementary. That is also a linear pair. Now we need to say that they sum to be 180 degrees. So measure of angle CAX plus the measure of angle XAQ is equal to 180 degrees. Same thing with the other pair. Measure of XAQ plus the measure of angle QAM is equal to 180 degrees. Since they are both equal to 180 degrees, they must be equal to each other. That is the transitive property. And we can say that they both have QAX or XAQ in them. So we can subtract that out. We are left with a measure of angle CAX is equal to the measure of angle QAM. And since their measures are equal, they are congruent. Okay? And so again, what we did was said that the blue pair of angles on the right was equal to 180, the blue pair of angles on the left was equal to 180. We subtracted this out and said, okay, if we subtract the same thing from both of them, they must be equal. Okay, we have angle A as a right angle. That's the definition of right angle. We have angle A is also a right angle. Definition of right angle. Actually, that's not what needs to go there. What needs to go there is the measure of angle I is 90 degrees. So angle I is a right angle, so its measure is 90 degrees. And the definition of right angle there, that was actually given, so my bad. These can be tricky. Angle A is a right angle, that is given. Angle A is 90 degrees because definition of right angle. Now they are both equal to 90. You can see right here, I is equal to 90 and A is equal to 90, so they must be equal to each other. Since they are both equal to the same thing, which is 90, that is transitive. And since their measures are equal, they are congruent. Angle A is congruent to angle I. And here we've got JQ is congruent to AW. That's a given. And QZ is congruent to WU. Those are both given. And we are asked to prove that JQ plus QZ, so this piece plus this piece, is equal to this whole thing. And that would make sense, because if the two line segments on the left are congruent to the two line segments on the right, and we add them up, they would add up to be the same thing. And that's what we're going to prove. So, measure of AW plus WU is equal to AU, that is segment addition. And what we're going to do next is, since those two pairs of segments at the top were congruent, their measures must be equal. So the measure of JQ is equal to the measure of AW, and the measure of QZ is equal to the measure of WU. And so now what we've got to do is notice that JQ and AW, their measures are equal, so I can replace AW here with JQ here. That is going to be substitution. And so basically what just happened is AW got replaced with JQ, so this line segment came over and replaced that one. And the other piece that we need to do is make this line segment replace that one. So we're going to have QZ replacing WU. And so QZ and WU are congruent. So WU is going to get replaced by QZ. That is substitution again. Okay. Down here with these angles, we are given that HIB is congruent to DEM. And that BIQ is congruent to MER. We are asked to prove that HIQ is congruent to DER. So it would be, we are asked to prove that this whole large angle here, make this red, is congruent to this whole large angle here. Okay, and so the way that we're going to do that is we're going to say that both of these angles are congruent to both of these angles, and so if I add up both of these angles, I'm going to get the same thing as I would if I was to add up both of those angles. We'll be doing some substitution for this one. So to start with, HIB is congruent to DEM, and BIQ is congruent to MER. Both of those were given. Now, since they are congruent, their measures are equal. So the measure of angle HIB is equal to the measure of angle DEM, and the measure of angle BIQ is equal to the measure of angle MER. Now DEM plus MER equals DER. We're adding up these two angles right here to make the larger angle. So that is angle addition. And then we're going to do the same thing for the other pair of angles, which is HIB. Plus the measure of angle BIQ equals the measure of angle HIQ. So we just added up both of these to say that they make the entire angle. And now we're going to go through a process of substituting these things in so that we can say that the two angles on the left sum to be the same as the large angle on the right. And so if we look at what we've got going on, we have BIQ is congruent, or is equal to MER. So here MER is going to get replaced with BIQ. So again, this is substitution. And then on the next step, we are going to be replacing actually, let me back up. BIQ plus DEM. Yep. So DEM actually got replaced by, or sorry, HIB got replaced with DEM. So we have BIQ plus DEM equals, no, right? So I've got to go off this one. So it still has DEM and it has MER added, so it is the case that BIQ is replacing MER for that one. And then the next one, we're going to be replacing DEM with HIB, because DEM and HIB are congruent, or their measures are equal. So then we can say that those are both substitution. And then we have that HIQ is congruent to DER because HIB and BIQ is congruent to HIQ. So we can replace HIB and BIQ with HIQ. And that is going to be transitive. Because their measures are equal, they are congruent, so angle HIQ is congruent to angle DER. That was a little bit complicated. Okay. Let's see, we have HID is a right angle. That is what is given. It is 90 degrees because definition of right angle. We can see that HID and DIZ are supplementary because of linear pair. And therefore their measures sum to be 180 degrees. Measure of angle HID plus measure of angle DIZ is equal to 180 degrees. And then because HID is 90, we can subtract HID from the left side and 90 from the right side, and that gives us DIZ, that leaves us with DIZ on the left and 90 on the right. That was just subtraction. And lastly, we have MUQ is congruent to JID. That's our given. We're asked to prove that QUW is congruent to DIH. So what we're going to end up doing is saying, look, that makes a straight line and that makes a straight line. That one and that one are the same. So if they both make a straight line, those two also have to be the same. So we'll start with what was given. Those two are congruent. Their measures are equal because definition of congruent. JID and DIH are supplementary because they form a linear pair. Because they are supplementary, they sum to be 180 degrees. Measure of angle JID plus measure of angle DIH is equal to 180 degrees. We have another linear pair, which is MUQ and QUW. They make 180 degrees because definition of supplementary angles. Now, these two are both equal to 180, so they must be equal to each other. That is transitive property. And then we have, they both have just put a typo in here or something. Nope. So since MUQ and JID are equal, we can subtract MUQ and JID from each side. We are left with DIH and QUW. That is subtraction. Because their measures are equal, they are congruent. Angle DIH is congruent to angle QUW.